All right. Well, I think Scott, we gotta respect time of everybody that's here. What do you say we get started and folks can trickle in as we get going? Does that sound good?
Sounds good to me.
All right. Well, wonderful. I will kick us off. My name is Rebecca Warren. I'm the director of product marketing at StackHawk, and with me today is Chief Security Officer and co-founder extraordinaire Scott Gerlach, Chief Security Officer to the stars. Um, we are thrilled you've decided to be with us this morning. For the first time, we are doing this workshop on helping developers go faster, safer. I will be here to kind of MC. I'll be keeping an eye on the chat in the Q&A. So if you have any questions or comments as we're going through this, drop them in that chat or Q&A box and we will get you answers. We love for these to be interactive and fun. Please don't hold your questions to the end. It's much more exciting when we get to answer questions you all have as we're going. So I'll be there. Drop in any thoughts you have and we'll get those answered. And leading this webinar will be Scott. He'll tell you a little bit about himself and what we have going on in this webinar today.
Woohoo. Thank you, Rebecca, intergalactic senator, I guess.
Of IT.
Well,
of IT.
Congratulations on that promotion.
Thank you.
Yeah. Hi, everybody. I'm Scott Gerlach. Hey, look at me. I'm the CSO and co-founder of StackHawk, as Rebecca mentioned. My background is in security. So as a CISO at SendGrid for 3 years, almost every job in security at GoDaddy, up to a senior security architect, almost 10 years there. I'm also a regular old husband, dad, brewer, golfer. I'm terrible at those last two things. And breaker of things around the house. So lots of times the Amazon package shows up and a new toaster's in there and people are like, why'd we get a new toaster? And I'm like, well, we don't have one anymore. If you want to talk to me, get a hold of me on Twitter. There's my Twitter handle as well as my LinkedIn handle. You can reach out to me if you've got questions or you want to just chat after this. Happy to do that. Let's talk about what we're going to talk about today. So we've got a pretty quick, short, sweet webinar here talking about how to make, as the title said, how to make application security help your developers go faster, safer. So a couple of sections we're going to talk about. First of all, we're going to level set a little bit why we do application security at all. Then we're going to talk about how to think about application security. And we're going to do a little bit of practical steps to help go faster, safer. So first of all, and as Rebecca said, if you have questions, put questions in the chat, put questions in the Q&A. Would love to try to be interactive, answer questions as we're going through this. Let's set the stage. I think sometimes we get wrapped up in the what and lose track of the why, especially in security. So let's talk about the why we do AppSec for a few seconds here. And we'll talk about, good things like some of the personal reasons I've given to engage or invest in AppSec in the past. These are things I've actually said. Okay, so there's some hyperbole in here, right? But some of these things are real. Some of these things are real things I've heard real people, including myself, say about application security programs. And so often we fail to connect the what we are doing with the why we are doing it. And in security, that is often a really tough kind of nebulous thing. So it's really tough to kind of wrap your head around, take your head out of this like task-focused thing and go, hey, I'm actually trying to help the business do something here. So it's to me, it's always kind of strange how almost every other part of the business has to let the business know why what they're doing is valuable to the company, except maybe accounting. They just go with like, do you want to do Excel and just kind of get away with murder? Okay, that's a joke. That's clearly a joke. Accounting serves a very valuable function, including helping you come up with reasons why we do AppSec. So all of these reasons exist in why we do AppSec, right? No, none of those things are why we do AppSec. Some of them are how we do AppSec, and we're trying to fix that today in today's webinar. But let's talk about some of the ways we can make our goals better known to the business and have actual measures you can model out for risk impact. This is not science insofar as you have an input and you get an output, but it's probably more complicated than input-output things. So let's talk about, again, why we're doing AppSec. I often hear this from security teams and engineering teams. I want to reduce my risk. Okay. And when I ask them how far they want to reduce their risk, the answers start getting real murky. Like the answers get real muddy around like, why are you reducing risk? And to what end? And how far are you reducing risk? So there's not a lot of great security metrics out there, right? This is one of the really hardest things to measure is how effective is my security program? Especially because we do things that are a little nebulous and silly, like, okay, in the Home Depot breach, they had 20 million records. I don't know what the number is, but this is just generalization. In the Home Depot breach, they had 20 million records, and each record cost 50 cents to remediate because of the breach. Now, in that particular case, that's $10 million. Let's say your company doesn't make $10 million or have $10 million of cash flow. Is it reasonable to assume that you are going to end up spending $10 million on 20 million record breach? No, it's not. You're not going to bankrupt yourself remediating in a breach. So that's a really hard metric to kind of measure, right? You can't just go, well, this happened to this company, and so that directly applies to my company. P.S. All those companies are still around. TJ Maxx is still around. Home Depot is still around. Target is still around. What happened to those companies was there was things in the middle that disrupted their operations. They're back in good shape now, but there was stuff that happened, breach remediation, legal things that happened, stopping all productivity on new technology and application development, all those good things. That affected the business. It didn't end the business, but it did affect the business. So like I said, there's not great security metrics out there. And if you ask CISOs about how they measure these things, they largely have gone to this narrative method. It's all about telling the story of security and why it's important and who it's important to and what we should be doing and why. That's great for a really seasoned CISO that has a ton of experience and has like a whole breadth of knowledge that they can bring to the table and go, in the past, when this has happened, here's what happens. But what if you're an engineering leader whose job is to deliver software? Your main focus is delivering software. How can you model some of these things out and help your exec team understand to what end you're trying to spend or to what end you're trying to affect application security? Here's some ideas, right? So mostly AppSec is about increasing customer trust. There's also some regulatory mandates that go along with that, but mostly we're talking about customer trust type issues. And so what we're talking about there has actual effect on the company in customer trust. We're talking about reducing cost of acquisition. And so if you have a business that tries to attract customers to come to it and spend money there, there's a cost associated with that. And sometimes that cost associated with it has to do with, does the customer trust the business? The greater the trust, the faster and less acquisition costs you probably are spending to gain those customers. Time to close is another good one on customer trust here, right? If you're working a deal, if your sales reps are working a deal with a customer and they have good trust built into what you're selling and how you're building and all those good things, the time to close can be a little bit shorter. And I'm not talking about like 30 days of shorter. That would be an insane impact and really, really good. I'm talking like a day, half a day impact. We're going to talk about that a little bit later. And then also protecting future churn. This is one of the big metrics that is probably very modelable in almost every business. If you can reduce or risk impact the amount of customer churn by 1%, that actually has a huge consequence to what the business is trying to run. Business is trying to do. Keep those customers from leaving because of a breach or some lack of customer trust. There's also regulatory mandates. Some of these are very, very specific. PCI 6.6. Some of them are very generic. SOC 2, ISO controls just kind of say do AppSec. They don't say how to or when to or any of those things usually. Financial controls, GDPR stuff. There's lots of different regulatory mandates that you might run into that have a AppSec component. Unfortunately, most of them are not very specific about what to do and when to do it. So I always like to think of building a great security program filters automatically into a regulatory mandate so that your audit program is just built on top of solid things that you're doing in the business already anyway. Okay, shift left. You may have heard this term and asked yourself, okay, well, what does this actually mean? You actually may know what shift left means, but does it practically mean in software development in AppSec what you think it means? You may actually know what shift left means in software development with AppSec, but are you doing it that way? And if you do know what you're doing, why are you here? No, I'm kidding. I'm glad that you're here. If you're killing it and knocking it out of the park, share some comments of what you've done and won, big wins that you've had in the chat or in the Q&A, or share with everybody. But let's talk about shift left. Why do we want to shift left application security? Here's some of the reasons we want to shift left on application security. These aren't the only reasons, but there are some good ones here that relate back to business metrics we talked about just a little bit ago. If you haven't done this, if you've never done this, go ask your sales team how much time security review takes in their deal process. Like I mentioned, if you could change that a little bit, what if you could change that by a day? How many more deals could a rep close if their security review or their deal review legal process with a prospect took 1 day less or half a day less? Could they close 10 more deals a year? Could they close 15 more deals a year? Really interesting metrics like small incremental changes here make really big impact. And if you think about it in the terms of the business, there's really good stuff here. As an engineering leader, you probably already have metrics you're trying to achieve. And those metrics are about how fast and how well you deliver software to the organization so that it can use that to attract and retain customers. Now we're starting to speak your language here a little bit, right? We're talking about a more predictable roadmap and less rework on change error rate, less requirements built onto the software, build them into the software. Also, if you're an AppSec pro, you're in high demand. If you're trying to hire an AppSec pro or AppSec pros, they're hard to find. So this is one of those reasons that shift left is actually really good, because you're taking it out of that, like, I need a small army of these AppSec pros to be able to scale my engineering team, and going, I need like 1 or 2. And they're going to act as consultants to my engineering team because I'm spreading out the load of finding to the engineering team and empowering them to make decisions. And then having these AppSec professionals go find really hard problems and consult on what things I should be fixing. There is another pretty well-studied AppSec shift left metric out there. Wow, I got that out without stumbling all over it. And that's the cost of fixing security bugs. So this is a really well-researched metric here. The relative cost to fix bugs based on when and where you find them. And so you can see the further you get towards production and into production, the cost incrementally goes up. It's a lot more expensive to find and try to fix security bugs when you get to production post-release. If you can tackle these things in the coding and integration testing phase, you've reduced the cost of fixing these things by 10, 20, 25%. That's significant reduction. And if you think about that, this whole relative cost, right? But if you think about that in terms of the time a Scrum team has to build software, just time alone, right? Let's say you add 10% to a sprint, or you add 30% to a sprint. Those are significant impacts. There's probably one less story you can do in a 10% add, and close to half of the stories that you can't do when you've got that 30%, 30 times going on. So as you're finding those application security bugs in production, and that's the only place you can find them, that costs you significantly more impact to be able to fix them. Now, there's a whole argument about like, cool, then we won't fix them, but that's not what we're trying to do here. What we're trying to do here is fix the things that are necessary to fix and do it at the right time. Let's talk about how to think about application security. And a lot of times we get stuck in this like checkpoint approval gateway process. And too many times this like, where does AppSec happen? It's in the wrong place at the wrong time. I spent, as I mentioned, 10 years at GoDaddy. Racing was a big part of GoDaddy. So we're going to have a little fast cars talk, as indicated by our little title here. Little fast cars talk here real quick. I had the privilege of going to many, many races, and I always saw the racetrack interestingly. If you take a look at this picture, what do you see here? Drop some stuff in the chat. What do you see in this picture? Anybody? Hello out there. That is because they sponsored number 10, Danica Patrick. She was very, very nice. And also, you know, fast cars is kind of cool. Whether you like F1 or NASCAR or IndyCar or whatever racing, this is cool. Lauren says she sees people in cars. I see this a little bit differently. Check this out. I see a lot of customers. I see a product out on the race course, and I also see a lot of security stuff. The faster this product goes, the more those customers are probably going to pay. I also see the work of the security team all over this thing. You got the safer barriers and the fences, safety features built into the cars, helmets. Okay, the helmets are hard to see, but they're there, trust me. Safety features and stuff built into the grandstand so people can get out of those things if they need to. There's security all over this picture. All of these security features are designed to do one thing: make sure the product goes fast. And if something bad happens, keep the product and the customers from being injured or dying. There's security all over the place. And their job is to help this product go faster. Remember, the goal here is not to make risk zero. The only way to do that is to turn it off and go home. If we want to make risk of this thing here zero, shut it down. Turn off the cars, send the people home, get out, walk. That's the only way to make risk zero. That's not what we want to do. What we want to do is manage the risk here to an acceptable level. And that is what application security in general, but application security is all about. Security teams should think like this. They're here to help the business and the product go faster, safer. Make sure that bad things don't happen. And if the bad things do happen, people don't get injured. The business doesn't get injured. The customers don't get injured. Definitely not die. But we're talking about helping this product go fast. So you will also notice that there is a lack of security features here on the road. There's no speed bumps in production here. That doesn't mean there aren't security measures in production. In fact, the security features dominate this image. There's way more security features in this part of the image than there are anything else. Safer barriers, fence, people working the stairs so people don't get down by the fence and get hit by debris flying off the track. That whole gap between the fence and the barrier or the stands, that's a security feature, safety feature as well. But what you don't see in this picture is a safety tech out there measuring cars as they're racing, trying to see what happens if the cars crash while they're racing. Okay, fair point. A lot of the customers in this particular thing are here to see what happens when the cars crash, but I guarantee you they don't want people to get hurt, right? They're here for watching the race, watching the product. Crashing is part of this product, but they don't want people to get hurt when they're doing that. You may have heard of chaos engineering before. That's kind of an AppSec program. Chaos engineering is basically dropping a bunch of tacks out here to see how well the product handles that problem and where the safety measures might fail. Now, that is a valid exercise, but it's a really advanced tactic, and most engineering shops aren't really ready for that. So Chaos engineering is one of those like, okay, I'm going to take it to the next level kind of thing. If you don't have a really solid application security program already in place and you're working on it, chaos engineering is probably not the right place to start. Now, we've got all this stuff for this product that's out here running fast. That doesn't mean that you can't have security checks. Doesn't mean you can't have rules. Now, for those of you that don't know, when NASCAR cars and F1 cars and Indy cars go out to race and come back from races, they do a tech check. And part of this is like that big thing that's sitting on top of the car is like an aero package. Like, is the car built the way that we said they got to be built? They're also checking a ton of other things in that car. Remember, all these rules and regulations and templates are available to the engineering teams during development. So you can't just like have this tech check station and not give everyone the information / ability to build these checks so that they know when they produce this race car to put it out on the racetrack that they're going to pass so they can get their race car out there. You setting good working agreements here and giving development teams the tools they need and the power to make decisions helps them to get to this point and have confidence that their race car is going to be able to run in production. Now, I can't stress this enough. This is not the only place that you can do this testing. You can't have some dev team show up with a 1968 Beetle to the Daytona 500 because you didn't help them with, here's the rules and the regulation and what the car has to be built like and how it's got to look. You can't put the aero template on the car, on the 1968 Beetle and then go, hey, sorry, I know you guys put like $50 million into building this really sweet Beetle, but you can't race because that doesn't look like a race car and it's dangerous. You just increase the cost of development exponentially by doing that. So remember, you can have really good checks before you go to production, but it can't be the only place that you are enforcing and enabling those checks. Now let's talk about your map to AppSec speed. For those of you who don't know, I bet Lauren knows what this track is. Maybe she doesn't. I don't know. We'll see. Let's see. How does AppSec testing happen today? So most of the time, AppSec testing today happens pretty infrequently. Most organizations, security testing kind of happens maybe weekly, monthly, quarterly, yearly. And that's super infrequent for how we're developing software today. That testing, oh, hey, look, people got Monza. All right, I like it. People do know that track. Sweet. Here we go. Testing only happens in production. So again, this is like going out on the track and going, all right, bring whatever you brought, and we're going to test things out on the track. That's not going well, shockingly enough. Long scan times, think about it like this. Your software has tests developed for it that are integration tests, unit tests, all kinds of like cool tests. Think about if the only place you ever ran those tests was in production and you were like, well, customers are going to test our software when they use it. And so that's where we'll get that feedback. Those customers won't be around for very long. So why do we treat security differently, application security differently than that? It's interesting to me that it's not just kind of an integrated part of testing. And then obviously testing resources are limited. We talked about those really hard to find application security people. They're really hard to, first of all, find, attract, hire, and they're almost impossible to scale at the scale that an engineering team runs. We were just at RSA a couple of weeks ago, and you're going to see the effects of what happens when I go to RSA and sit next to a booth. But one of the interesting things in the keynote there was headcount ratios. Headcount ratios were 100 devs to 10 CI/CD or DevOps people to 1 security person. That's 100 to 1. Think about how hard that one person is working to keep up with 100 engineers. That's insane. That does not scale. This is why we've got to spread out this tooling and this information to make it more democratized throughout the engineering organization. Joseph has a question. Do you think static code testing with CI/CD can help with speed of testing? Yes, but I also think that the only place you run static code testing cannot be CI/CD. You cannot make developers push code into CI systems to have it be checked there. That's not how linting works. That's not how unit tests works. That's not how integration tests work. That's not how any of those tests work. They may only run them in CI/CD, but I guarantee you if CI/CD breaks because of one of those tests, they bring that code, load the code back up on their laptop, and they go, all right, that unit test failed. Let me step through the code. Security testing should work the same way. You can instrument security tests, application security tests in CI/CD. It can't be the only place that it runs. You have to give the engineering team the power to be able to run those tests, recreate the problem, and have confidence that when they push code, the test is going to pass. You can't make them go, okay, I think I fixed it. Push. Nope, still broke. Okay, well, okay, I think that fixed it. Push. Nope, still broke. Okay, I quit. I'm going to unwire that thing because it's keeping me from getting my job done. And so there's no silver bullet in application security testing, right? There's no one thing that's going to get you to, it's 100% secure. We talked about zero risk. We talked about a lot of different stuff in this presentation so far in this webinar, but there's no silver bullet for application security. You need tests that run against code and tests that run against the app to be able to consume those things. And we're going to talk about what happens when you can put those things together. But any testing that you want to shift left, like I said, has to be something a dev can run, consume the results and action themselves. You can't do chuck left. You can't throw a security tool at the engineering team and hope it will turn out well. If you're not letting devs triage and make decisions with the guide of your working agreement, you're not shifting left and you're not going to succeed. What you're doing is chucking left. I chuck this tool at them and I won't let them make decisions because they'll make the wrong decisions. Okay, cool. Making the wrong decisions is okay. That's a coachable, workable moment. Making zero decision is not coachable. It's not discussionable. It's not collaboratable. Wow, that's a word. Did I make that word up? Rebecca, write that one down. We're going to put that in the next webinar. Collaboratable, like faster.
We'll write a white paper on it.
Safer and collaboratable. Anyway, you get the point. You need a testing session, just like our race cars don't just show up at Daytona 500. They don't show up at Monza and go, I hope this works. You got to have a testing session for your race car, for your speed production. So a testing session for how to get this working well in your development organizations. Engage with a project team in their pipeline. How do they do work? How can you build or help them build security tools into that pipeline so that they can actually use it? Choose an application or a service, maybe something medium critical, high critical. I don't know. Pick something that you care about and that you get good engagement with the engineering team. Choose a technology. I always say SAST or SCA and DAST are good places to start. We're going to talk about SAST and DAST. And for those that don't know what that means, I'll get to that in a little bit. And then once you get that testing session done and you have good success, iterate, keep going, expand to other teams, expand to other apps. And remember that test-driven security should be instrumented in CI/CD, and it should work like other tests. When the unit test fails, you can recreate that on your laptop and it will tell you. And then if you push and ignore that, CI/CD will tell you the same thing. Integration tests, compile tests, linting, all of that stuff is available on your local machine and in CI. Remember, they have to be parity. If you have one thing that only works in CI and doesn't work here on a laptop, you're not going to get developer engagement to fix those things because it's too hard. It's too hard to understand what's happening and why it's happening and be able to recreate those problems. If you push an application to production and a user goes, when I do this and this and this breaks. An engineer can recreate that. I do this and this and this. Oh yeah, that sure does break. If a customer goes, hey, if I look at the website, it's broken. If I look at the application, and I think really hard about cookies, my thing breaks. And the engineer goes, huh? Okay, I got it running, and I'm thinking really hard about cookies, and it's not breaking. I can't fix that. That's unfixable. It has to be able to be recreated in both places. Today, most teams don't know when they introduce vulnerabilities into the code because of this. By the way, that's what StackHawk is here to do. So small marketing things going on. Remember, the right time to do all this stuff is pre-production, pre-racetrack. You can have that tech inspection before you get to the racetrack, but that can't be the only place. So local dev and CI/CD, while you're writing code, while you're building code. StackHawk customers check for security bugs on every merge, and they have the ability to quickly test locally when troubleshooting a fix there. You can test while you're writing code, and you can test while you're building code, and security tools should play well in those phases of development. Remember, that's really important. Now, let's talk about going to buy AppSec tools. Buying AppSec tools is one of the most challenging things because a lot of words and things and stuff are very confusing. But let's talk about why it gets this way. When I say, Joseph has a question here, when I say recreate fixable, are you discussing whether a vulnerability is exploitable or not? No, I'm talking about just being able to recreate the same test that is running against an application to recreate the same issue, right? So there's a whole conversation about DAST and SAST and other technology. DAST, I think, does a good job of, is this vulnerability discoverable and exploitable? Probably. SAST has a different kind of spin on that, where it can point into the code where you need to be fixing it, but it's not really telling you if it's discoverable and exploitable. And we're going to talk about why these two things are very powerful together. But I'm just simply talking about if a test fails and raises an issue, being able to recreate that same test on your local machine for a developer so that they can recreate that problem, fix the problem, retest there, have confidence when they push to CI/CD. Who usually buys security tools? All right, like I said, we spent some time at RSA recently, and we were next to this booth that had a time machine, a DeLorean, and I may have worked a lot of that into this because my brain is broken now. Here's how security tools get bought today. The security team goes out there and does all the searching and all the research and all the testing and all the proof of value, and they make decisions. This works fine for a majority of security tools, as usually the security team is the only one using them. However, we just talked about this. The security team is not the only one using them in AppSec land. Application security necessarily needs the product team and the engineering team to agree and buy into how we're going to use this thing, the working agreement of what things do we fix, when do we stop CI/CD builds, all that good stuff. If your goal is to help your product delivery team go faster, it seems like there's some people missing in this picture. McFly, that's not going to work. You're not going to have buy-in or agreement from those teams on what you're buying or how you're going to use it. It's just flat not going to work. And what you just bought there, if you're a security team, or even an engineering leader, or anybody in the org, if you don't have buy-in from those other teams, you just bought shelfware. You're going to try really hard to get it rolled out. And what's going to happen is you're going to run into a lot of friction, and you're not going to be able to use the product to its benefit, to its fullest benefit, right? If you buy product that's supposed to be helping you go faster, safer, collaboratable, and you don't have buy-in from those other teams, it's just not going to work the way you want it to. So instead, if you can't get those three teams to participate in looking for AppSec tools, you haven't done a good job of soliciting why AppSec is important to your company or to their roles. Like, it's even important to these people's roles, and soliciting that and talking to them about it is really important to being able to go looking for AppSec tools. These two groups should be an easy sell with some of the metrics we talked about earlier. More predictable roadmap, more quality software being put out there, less rework, less error change rate. Where we usually get hung up is how this process works. If you include them in developing the process and the tools, you have a much better chance of success. That doesn't mean they have to go to every call. Doesn't mean they have to go to every evaluation session, but you should work out with them early what tools you want to, what process you want to follow, what tools you're looking for, And when you get to, I think this tool will work, get them into the evaluation, get them into looking at it and participating in evaluating what tools you're looking to buy. Because if they participate there and they go, actually, this will work really well, and I think the process that we've set up is going to be really good for us, you've already built a much more successful application security program, and you haven't even bought a tool yet. Like, that's an amazing step. Now, remember, this is not a Doc Brown problem. You can't go fix what has happened. You can't go fix in the past broken relationships from teams or people that may have broken down or built silos, broken down relationships. You can only affect the now and hopefully the future, right? So if those teams are reluctant to participate, you have a tough road ahead. I'm not going to lie, but don't give up. Let them know that you're trying to help them achieve their goals, not just your goals. Like AppSec as a security person is not only your goal. You're trying to help the product and engineering teams go faster, safer. And like I said, there's a lot of Back to the Future stuff. I kind of just have Power of Love and Back in Time stuck in my head constantly, and it bled into this presentation. So hopefully you like my funny little jokes. If you don't, then wait for the next workshop of slides. No, I'm kidding. Thanks for coming. Types of tooling that you can choose from. We talked about SCA a little bit, software composition analysis, really good list of vendors here. Checks a database of known vulnerabilities in library versions based off dependencies pulled into your project, like package.json, Gradle, those kinds of things to help you go, hey, you're using vulnerable software packages or open source software. You should upgrade them. Static application security testing, SAST, scans your application's code and looks for patterns in the code that can indicate a vulnerability. So you can find things like SQL injection in code that you wrote, or cross-site scripting in code that you wrote, or insecure direct object access in code that you wrote. What it doesn't tell you is, whoa, we forgot to delete the slow part of this. Not slow, fast. Depending on which one you choose, there are some slow ones. What it doesn't tell you is this discoverable and is it exploitable? That's where DAST, I think, comes in really nicely. And dynamic application security testing sends web traffic against your running application and API. It looks for patterns in that traffic that can indicate a vulnerability. Again, finding SQL injection, cross-site scripting, lots of other good stuff, cookie safety, HTTP headers. This can be slow. And this is part of that old mantra of we test in production. So we test out on the track. Imagine chasing after the cars, racing around Daytona and trying to test them. Probably not going to work because you either need to make the cars slow down or you got to be really ripping fast. If you test while they're being developed, those cars are standing still. They're easier to test. The tests can be faster because you're not slowing down production. So remember, both of those things can be fast if you test them in the right place. And those last two things really test and check for mostly code that you wrote. So the things that you are, the IP that you're putting into the applications you're creating. After you've got that single tool, try correlating some of those findings. So this is a really cool integration that we launched recently with Sneak Code that integrates DAST findings and SAST findings and puts them together in the UI. So you can see some really interesting little icons here in the StackHawk UI with Patch, the Sneak logo dog. Helps you understand where to focus. So now you can really build some really good working agreements with your development team and your security team and your product team to say, hey, if we find a correlated finding, we want to triage that before we go to production. If we find and highs, so any highs that we find, we want to triage, hopefully fix before we go to production, and any correlated findings where you see the patch logo. We want to be able to fix those. We want to triage those, hopefully fix them if we can. And if they're false positives or we think they're risk accepted, okay, that's fine too. Make that decision, document it, and move on. But hopefully what happens when you have these correlated findings, remember DAST is testing the application outside in. So it doesn't really point at lines of code. And SAST is pointing at lines of code, but it doesn't know if things discoverable and exploitable. When you put these two things together, it goes, hey, this is discoverable and exploitable, and here's the lines of code you need to go fix this problem. That's super powerful and and very much helps an engineer go from, okay, what is this problem to, oh, I know what this problem is and where this problem is and how to fix this problem. Hey, guess what? I'm fixing this problem. And that's really what we're here to do, is fix application security problems, because we're serving the business. We're trying to decrease customer acquisition costs by avoiding a breach. We're trying to have a more predictable roadmap and avoid a pen test showing up with 50-page PDF that we have to undo 2 sprints of work to just work on those security issues. All of those things are valuable to the business. And what we're trying to do is do little incremental checks. Find little things as we're developing code, because then there won't be a giant PDF, 2 pages that is just like, boom, we got to fix all this stuff and we can't do anything else for a month. That helps. All right, warning. I'm not saying this is easy. You might have to have a therapy session or 2 or 50 therapy sessions to be able to figure this out with your product and engineering teams and security team, but it's totally doable if you focus on why are we doing this. If we focus on why are we doing this and what should we do it with, what are the most important things to do it with, trust can be built back into those teams. Undo those silos, undo the securities over here, product delivery teams are over here, and security keeps moving farther and farther away with their little tools. And they're like, yeah, these are mine. I'm going to go hang out by myself. See ya. You don't want that. You want these teams all working together because they're all trying to do the same thing. Product delivery teams, application security team, application security team should probably be part of the product delivery team, by the way. But really kind of hammering out problems that have happened in the past, why or why not application security is valuable to what we're working on, and going faster, safer. Really quick, we're at the 41-minute mark here. So questions and answers coming up. If you have any questions, recap what we talked about. Application security is a business problem, so treat it like one and not a fun hobby. Remember, you're trying to affect something in the business. You're trying to affect some outcome in the business. Map yourself to the outcome. Maybe you're trying to protect customer acquisition cost. Model out what a 1% increase in customer acquisition cost looks like. I bet the finance team can tell you that with their fancy Excel sheet for sure. What does that look like? A breach could raise customer acquisition cost 1%. What does a model out look like? I can save 1 day or half a day on security review in a deal with the sales team. Ask your product leader, hey, if I could give you a more stable roadmap by not blowing up your roadmap. Almost every product leader in the world is familiar with the situation where somebody comes walking in all proud face like, hey, I just bought a pen test and I got this really thick report. We got to do all this stuff. Almost every one of them has a story like that. Ask them what it would do to undo that thing, to undo the conversations of, oh man, we got to fix all this stuff. Ask your engineering team what it would be like. Ask them to start modeling out change error rate as a security thing. Like, what part of your change error rate is a security problem? And what would it do to be able to reduce that? What would it do to be able to reduce change error rate, quality of software, increase quality of software? Add the security testing, build enablement, not speed bumps. Remember, we want to make production go fast. We want to do all our checks before we get to the race. Those simple checks that you can do greatly improve your security confidence. Simple tools that you can run that give you simple information, consumable information, feed that into the engineering team so they can make decisions on it. That alone greatly improves your security confidence. And by the way, when you do other stuff that's still necessary, pen tests, those are really good brain problems, human brain problems. You get more value out of those things because you're making them do hard work, not just go, well, I ran a tool and it found me a lot of things, so I'm done. I'll take my $20,000. Thank you. DAST, again, I think is a great place to start. If you haven't already, add more tools to that later as that works and helps you go faster. Make CI/CD systems keep you honest. Allow technical inspections to keep your car safe, right? Remember that tech inspection with the arrow thing that goes on the car, similar thing that goes on in CI/CD, but remember that's not the only place that it can run. You can't just have a black box thing in CI/CD doing testing and keeping cars from getting on the track. Like I said, black box equals bad. Those tools should be able to run locally. And then make it part of your normal development workflow. Use tools that allow you to triage as an engineering team. Consult with the security team on what to fix. Don't put the onus of finding in the security team, because that is not where the value is. The value is in fixing. The value is in what should I fix and when should I fix and how can I fix it. The value is not in, look at it, I got 2 pages. I got 2 pages of PDF and it's sweet. All right, questions. I got one question Joseph asked. I think Zap has a new plugin to upload code while doing the DAST. Have you used it? I don't know what plugin you're talking about. I don't think Zap has any static code analysis tools. Zap does allow you to ingest open API spec, which is specifications of code, as does StackHawk. But I haven't seen anything that allows you to upload code to Zap. Good question, though. What else? Anybody else have questions? Rebecca?
I'm just back to moderate, Scott, but we did get a question directly to us in the chat, which is how can I get these slides? We will be sending out a recording and slides after we wrap up here and get all of this uploaded. So if that is your question, we will make sure to get that to you. But I'm sure there are much more exciting questions out there as well. Drop those in the chat or the Q&A.
Yeah, ask questions. If you got questions or you want to challenge me on some of my maybe shenanigans, I don't know. Seems legit to me, but I'm just one person who has paid for my own recording albums and store them in my mom's garage. If you missed the joke at the beginning, wait for the recording. How do you address false positives? That's a good question. False positives are a thing, right? They're a thing. If you allow engineers to go, hey, I think this is a false positive, I can't recreate this, I need to move on, then have them mark them as false positives and stop bothering them. Stop trying to gather their time, own their time. If you have a specific question about false positives with StackHawk, I encourage you to write into support, talk to your sales rep to talk about how to address and how to tune the scan so it can be better for your application. But false positives are a thing in application security, and you just have to have a way to deal with them, right? First of all, tune the tool for what you're building, how you're building it, what technology you use in it. Tune the tool to be the smallest piece of code that you can test. And then if false positives show up in there, mark them as false positives. Seems like a legit way to address false positives to me.
All right, Scott, I have a question for you.
Okay.
You talked about security teams working with engineering to build what evaluation criteria looks like for tools and then bringing them into that process.
Yep.
Can you talk about what has made you successful in doing that and maybe an example of how you've done that in a previous role?
Yeah, sure. So, that it's not an easy challenge, but it does do simple things like, hey, if I introduce a new tool into the development process, where should it run? Get the expectations out of product's head, out of the engineering leadership's head, from engineers. Get that into documentation so that you can go, okay, this is part of my evaluation criteria. Can said tool do what my product and engineering teams want me to do? And then when I get to, okay, we're testing it and I think it's good, show them that it can do what they asked you that it should do. So that's super important. I think just sitting down, if you haven't had a conversation, if you're an application security leader or person or CISO, and you haven't sat down with your head of product or VP of product or somebody who's in charge of product and your engineering leadership and said, hey, what's working in our AppSec journey today and what's not working? What if you could wave a magic wand, what would be the perfect scenario? Just have that conversation. That's the start of, it's actually super valuable. And this is something that I've done. It's super valuable to hear where they have visibility into what sucks and what's good. And usually you get the list of sucks. But just hearing that will help you go, oh, okay, I need to think about this in a different way. I need to think about not bringing stuff late to the sprint and interrupting the sprint at the end of the sprint. I need to think about how can I integrate this into a developer's work day. Those kinds of things are very important. Cameron has a question. How would you get tools like Zap into developers' hands? Suggestions on how to enable your engineering team so they can use Zap while writing code. Well, the suggestion I have for you there, Cameron, is going to be very salesy. Use StackHawk. StackHawk is built on Zap, and it's built to do exactly what we're talking about. Shocking surprise to no one in this webinar, sponsored by StackHawk, with the CSO and co-founder of StackHawk. Zap is a super powerful tool, super powerful DAST tool. It's terrible UI, terrible. If you are not a Zap professional, if you don't use Zap every day, you almost can't use it. We do. We made it super easy to use and super easy to understand the output and super easy to reuse. That's my answer to you. Zap does not have a Jira integration. Correct. StackHawk does. Have a nice day. What else? What other questions do people have? Zap takes a while to get used to. Once I did, I stopped using Burp. I agree. Zap is a very powerful tool. And if you are an AppSec professional and you want to use Zap to do your like point in time, deeper testing, not your automated testing. You don't want to do like, hey, I want to use, I think StackHawk is easier to use in automated testing and easier to output results and deliver those to engineers. But if you want to use Zap to do your like deeper testing, like I want to go look at my critical applications in the business and see what kind of logic flaws or business logic flaws exist in it, or deeper like brain thinky tests. That's valuable. You can use Zap. Kind of gives you the same kind of output that StackHawk does. And you'll get consistent results because you're using the same kinds of tools. Any other questions out there? I super appreciate everyone spending an hour with us, 50 minutes with us. Here's a good question. I get a lot of pushback from engineering about fixing security issues due to the large backlog we have for security since the startup company has just onboarded AppSec tools. How can I expedite the work? Stop trying to get them to fix the backlog. Triage all that stuff and go, hey, we should fix this at some point. Can we take care of the new things that show up? Can we work on a process to address new things that show up? We have this like huge list of tech debt. That's all security problems are, is tech debt. There are tech debt sprints. People work on tech debt. See if you can talk about that in a tech debt fashion, not a security fashion, because it's tech debt. But also work on your agreement. How do we address new things that show up? I would like to get tooling and information instrumented into the development process so that when new things show up, we know about them and we can try to address them as they show up. The backlog is a whole different thing. The whole tech debt thing is a whole different thing across many different things other than AppSec. Try to work on new stuff. Try to get information about new things into people's hands so they can address so they can address them and fix them as they show up, not later. So you're not adding to the tech debt backlog. You're trying to help inform them as they're building.
Scott, I gotta, maybe it's pushback, maybe it's a follow-on question to that. What if you have some really severe vulnerabilities in that backlog? How do you work with the team to get that most important stuff fixed, so then you have a baseline you're all really comfortable with moving forward? Or you say just focus on the new stuff?
Yeah, this is all part of your discussion with your product delivery team, right? If you're talking about why is this important and it's a high vulnerability, no one cares. Like this vulnerability is high. Okay, what does that mean? It means we could be breached. Okay, cool. What does that mean? Breach? You gotta relate that back to some of those things. Talk about the metrics and the numbers that the business cares about already. Relate what you are doing to those metrics that the business cares about already. Whether that's top line revenue, customer churn, I guarantee you customer churn is in there. Customer acquisition cost, if you're any kind of a SaaS platform, there's tons of metrics that the business cares about already. Understand what they are and try to relate what you're trying to do to those metrics. Hey, if we don't fix this vulnerability, it could mean a loss of customer trust, which increases customer acquisition cost 0.5%. Increases customer churn 0.5%. Maybe that's potential. There's a real number associated with doing that. And that's a real number the rest of the business cares about. It's not just like some nebulous, risky number. Try to model that into a number that people care about. How's that for an answer, Rebecca?
I love that. I love that advice. And, translating what you as a security person know is really important to what other people can also understand.
Yeah.
It's a great takeaway from this whole webinar. Last call. We got 3 minutes. Who has one more question or otherwise? I think that wraps up what we have, Scott.
Awesome.
Any parting words for folks?
Yes. First of all, thank you, Rebecca, for moderating and helping put on the webinar. And congratulations again on your intergalactic representative promotion title. Thanks everyone for coming and enduring my silliness for an hour. Hopefully you found some of this information valuable and some things you can take back and go try to work on at your place. And lastly, Stanley Cup final game for tonight. Go Avs.
Go Avs. All right. Thank you. Have a great day, everyone. And thank you, Scott.
Thanks, everybody.
Bye.